can give you guys a full access to what we're going to be doing. So if you ever need to pause this, feel free to do so, and you can kind of see what we're going through. So today we're looking at valence electrons, Lewis dot structure, and also we're going to be looking at the octet rule. So follow through. If you need to pause, once again, feel free to do so. The objective is up on the board. I've talked about what we're going to be doing, but you'll be able to determine the amount of valence electrons from the periodic table today. You'll be able to draw them out. You'll be able to draw out Lewis dot structure, and then you should be able to also tell me what elements bond with each other based upon where they're at. So let's go ahead and get into that. So valence electrons, as we know, are the outermost electrons. They're the ones that are the farthest out in the orbital. If you're looking at it from a standpoint of a circle, it is the outermost circle. Remember, you have your nucleus here in the middle, and it is this outermost circle. That is the most important in bonding because that's where we get into like the sharing and things like that of the electrons. So how do we count the amount of valence electrons? It is very easy. And we're going to find that on this next slide whenever we go through it. It's already numbered. You guys should have your periodic table as well so that you can see the numbers. So here's what we do. You look up at the group. The key part there is the group number, which you should have labeled. It goes from 1 to 8, otherwise known as 1 to 13 through 18. But I told you guys to write down the 3, 4, 5, 6, 7, 8 because it helps you out. And whatever number group it is, that is how many valence electrons you have. So if we're looking up at the top number, and I'll go to the next slide so you can see, if it's a 1, and I'll draw it out with you. If it is a 1, then it has 1 valence electron. If it is a 2, it has 2 valence electrons. Now remember, these will be on that circle, not like how I'm doing it. If it has 3, it would have 3 valence electrons. 4, 4. I know this is kind of getting repetitive, so we'll go. And then all the way up here to 8, and it would have 8 valence electrons. So whatever number it is in, so 5, 6, 7, 8, 1, 2, 3, 4, that is how many it has. So let's say I'm looking over here at hydrogen. So I'm just going to draw hydrogen out real quick. Hydrogen is in group 1. That means it would only have 1 valence electron. If it's in group 3, so let's see boron. So boron is in group 3. So that means boron would have 3 valence electrons. And it doesn't get any more difficult than that whenever we're looking at determining the amount of valence electrons established. So let's go ahead. We've got some time, so there's a couple that we can go and do on the next slide. Oh, sorry. Before we do that, we're actually going to look at Lewis dot structure. So I told you before how we're going to find the number of them, but now we can actually go and draw out those valence electrons in what's called a Lewis dot structure model. So the Lewis dot structures are ways to show the number of valence electrons, and whenever we do it, we only do a max of 2 per side. So if you look at the X's, there's 1 here, 1 here, 1 here, 1 here, and then 2 over there, and then 1 down here. The reason why we have an empty X here is because if you look at bromine, and I'm going to go back to the previous slide. Oop, sorry, wrong way. Bromine is over here in the 7th column, or 7th group, which means it would have 7 X's, or 7 dots. And so, because it's in group 7, it has 7 actual dots. The other one's empty because, it doesn't have anything there. That is the potential of bonding. That's where we would find bonding happening. So let me clear this real quick. And we're going to go to the next slides, and we're going to determine some Lewis dot structures for certain elements. So we're going to do 2 of them. And then the other two I'll let you guys kind of do on your own. But first one we have neon, and the other one I have magnesium. I'm going to remember those, that way I'll circle them right now, that way I know that we're doing those. So here's magnesium over here on this left side in group 2, and neon is over here in group 8. I'm going to do neon last because that's a lot of dots to do. Okay, so magnesium, all we're going to do is write out the element symbol of Mg. Alright, I wish I had my stylus to make this a lot easier. And then all I'm going to do is do a max of 2 per side. Now I kind of do it a different way. I just go 1 and then I go to the next side. I do 2. Some people would put it like over here. But all I know is there's 2 X's. It's in group 2. That means this is what my Lewis dot structure would look like. Neon, so what I do is I write out the chemical symbol for neon, which is Ne. And I know neon is over here in group 8. It is full. It has already 8. So I'm going to do neon a little bit differently, and I'm going to just do dots. So I do 1, 2, 3, 4, 5, 6, 7, and 8. So in total there are 8. It has a full valence electron shell, and that's all we would do. So we could do a Lewis dot structure. Now some people, like I said, do it with the X's. Some people do it with the dots. Either way, it doesn't matter. But just make sure there's a max of 2 per side, just like you see here on each side. And for neon and all of these over here in this 8th column, this is our side of noble gases, so those will always have 8. The other ones, whatever number group it's in. So let's go ahead. We'll clear all that. We're going to move on to the last step, which is essentially just incorporating the octet rule. So if we saw here with bromine, bromine had 7 valence electrons, but we do see that there's a missing X. That means there's the potential of bonding with bromine that we would be able to figure out what goes with it. And once again, we're just going to use the periodic table to do that. But let's look at what the octet rule says. So you guys will probably need to write this down. I'm going to go through it quickly. But essentially, the octet rule says that an element wants to have 8 valence electrons. And if it's 8, it's happy. I kind of think of it like you guys at lunch, that once you've ate, you're happy. You won't share your food with anyone else because you've already ate. So in the same way, elements, once they've shared and get to that 8, then they themselves are also happy. So how do we determine what they're going to share with? Well, it all depends on where they're at on the periodic table. And let me look at, I talked about noble gases already. So noble gases already have 8 valence electrons, which is a full shell. So that means they don't bond. It's very hard for noble gases to bond, especially on their own. You don't really see that happening. So they're the most stable. It's like once you guys have eaten, you guys are stable. So once they have those 8 valence electrons, they won't share. They're good. They're stable. They're happy. But other elements are not as happy. So if I was to go and draw a Lewis dot structure for like hydrogen. So hydrogen is over here in group 1. That means hydrogen only has 1 valence electron. That means it's missing all these other 7. So what I'm going to do is do a little bit of quick math. If I have 1 and I need 8, so 1 plus 7 equals 8. So that means hydrogen would bond with anything from group 7. Now let's go on. I'm going to change the color, make it a little bit easier. All right, so we got group 2. Let's say I've got beryllium. Sorry, this is a bright yellow. Beryllium is in group 2, which means it has 2 dots. That means it's missing 6 to be full. So it would bond with anything from group 6. And that goes vice versa as well. So I've got anything from group 7 that has 7, it would want to bond with anything from group 1. So this is kind of why I'm color coding it. If you have oxygen or anything from group 6, it would want to bond with anything from group 2. Now let's say I have boron or nitrogen or anything from group 3 or 5. We know that 3 and 5 together equals 8. So groups 3 and 5 would bond together. And then our final one is group 4. Group 4 is right there in the middle. It's that happy middle. So it would bond with anything from its own group. We can get into more complex bonding later on, but for right now, we just really want to make sure that we understand that if it's how many ever it's missing, that's the group that it's going to bond with in order to get to 8, because 8 is that happy middle, that happy number. And that's pretty much the basics of bonding. If you need to go back and look at anything else, feel free to do so. I'll go through quickly. So neon, we know, would not bond with anything. Magnesium is in group 2. That means it would bond with anything from 6. Carbon is group 4, so it would bond with anything from group 4. And sulfur, 6, so it would bond with anything from group 2.